Okay, here are some video solutions for section 9.9 representation of functions by our power series. So the first one we're going to look at is this one, which looks like it's in the form of a over 1 minus r, which is the sum of a geometric series. So that we could probably change this to a geometric series just by using the sum form. So if we can get this into a over 1 minus r form, we can find the geometric series that represents this function. So first thing I'm going to want to do is it's centered at 4. So that means we're going to need an x minus 4 as part of the ratio. So first thing I would like to do is take this series. 2x is going to be the ratio. But I want to make it centered at 4. So instead of 2x, I'm going to make it 2x minus 4. And to even that out, I need to add 4. So knowing that I want this to be 2 times the quantity x minus 4, I'm going to distribute that 2 back in, but do it so I'm distributing it to the first 2 terms and then to the last term. So the whole idea is I'm just rewriting this. I'm not changing it at all. So I'll have 7 over 7 plus 2 times x minus 4. Now I need this 1 here, so I'm going to divide by 7, top and bottom. And now I have it looking a lot better as the sum of a geometric series. Now it even looks even better yet, minus a negative. So this is the result of a sum of a infinite geometric series. So it would be the sum as n goes to from 0 to infinity of a, which is 1, times r, which is negative 2/7, times x minus 4 to the n. You can see that's just a simplified version. They're just raising negative 2/7 to the n. So that's it. Now the interval of convergence would be, for what interval would this geometric series have a sum? Well, we already know that. We know that r has to be less than 1. So we know that negative 2/7 times x minus 4, which is r in this case, has to be less than 1. So absolute value. So I'm going to multiply by absolute value makes that positive, obviously. I'm going to multiply by 2/7 or 7/2. And then I'm going to 7/2. X must be 7/2 before 4 and 7/2 after 4. So we have 4 minus 7/2, which is 8/2 minus 7/2, and 7/2 plus 4, which is 8/2 plus 7/2, and there's my interval of convergence. Question number 2. Same thing. This one might even look a little bit easier. I'm trying to get this in the form 1 over, or a over 1 minus r. It has to be centered at 2. So this x is going to be my r. It's almost there. But the thing is, I need this x to be, I need this whole series to be centered at 2, so I need an x minus 2 in there. So now I'm going to add my 2. I'm going to distribute that negative, but I'm going to do it to the x minus 2 as a quantity, and then to this minus 2. So I will have 1 over 6 minus x minus 2. So I need this number right here to be a 1, so I'm going to divide everything by 6. That changes my a, obviously. So now I'm ready to go. This is in the form of a sum of a geometric series. So it would be the sum as n goes from 0 to infinity of a, which is 1/6, times r, which is 1/6 times x minus 2, to the n. Now, if you multiply this out, you'll get 6 to the n here, times 6 would be 6 to the n plus 1, which is where this comes from. But just make sure if you do that, you realize that this whole thing is the radius. So if you want the interval of convergence, you need to make sure that absolute value of 1/6 times x minus 2, which is the whole ratio, I think I said radius, is less than 1. So x minus 2, absolute value, must be less than 6, which means x has to go from 6 minus 2. I think I screwed up. Hold on a second here. To 6 plus 2. So I think they screwed up here, but you can check on that. But that's my interval of convergence is 4 to 8, not negative 4 to 8 like theirs is. So that's that. All right, so the next question. Actually, hold on a second. What did I just do? I'm sorry. This is a bad video. My center is 2. I subtract 6 from it. I don't know what I was doing there. I'm sorry. That's a mistake we make. The radius is 6. My center is 2. So 2 minus 6 is negative 4, and 2 plus 6 is 8. So, yeah, they are right. I thought that's a brain fart there. So we won't cut that out. Number 3. Okay, number 3 is the same thing, except look, we have an x squared here. And to deal with an x squared, you just deal with it. It's really not going to screw us up that much. We still want to put it in the form a over 1 minus r. So the first thing I want to do is, it's centered at 0, so I like the x minus 0 aspect here. There's not much you have to do with that. I need this 4 to be a 1, so the only thing I'm really going to have to do is divide everything by 4 and go from there. So this would create a sum a is 5/4, r is 1/4 x squared. So now this is what they have here. If you look at this, by the way, this is fine. we can leave it like this. And I like it like this because I can clearly see the radius. But we just raise everything to the nth. So we have 5 over 4 times 4 to the n down here, x to the 2n up here, and then 4 to the n times 4 to the n would be 4 to the n plus 1. So that's where their simplified answer is coming from. But let's look at the interval of convergence. So the ratio, this, has to be less than 1, which means x squared has to be less than 4. So when is x squared less than 4? Well, you can figure that out. It has to, if negative 2 and 2 would be the limits of the ranges, and anything greater than 2 or less than negative 2 would make this greater than 4. So really between negative 2 and 2. The other way you can think of this is, I don't know, I always think of it like this. It's like a parabola being less than 0. You know, this parabola goes from negative 2 to 2 for the intercepts. So it's less than 0 from negative 2 to 2. So any way you think of it, the interval of convergence is negative 2 to 2. Now, remember, we're so used to checking the endpoints of the interval. You don't need to do that when you're looking at a geometric series. We had to do that when we're using the ratio test, because the endpoints where it would equal 1, and when it equals 1 in a ratio test, it's inconclusive. That's why you have to check the endpoints. But when you're dealing with a geometric series, we know that the ratio must be less than 1. So there's no need to check the endpoints. If it equals 1, it's not in the interval of convergence. So that's why we can stop right here. So there's a couple more questions. This video is getting a little bit long, so I'm going to stop it here and do questions 4 and 5 in the next video.